we want to find the limit of the vector function that is defined by this cos t, sin t, ln t. So to do that, we take the limit of each individual function. So limit as t approaches 0 of cos t. So this will be the same as the limit as t approaches 0 from the right of cos t, then limit as t approaches 0 from the right of sin t, then limit as t approaches 0 from the right of, we can write this as t over ln t over ln t to the -1. Now we are doing this because if you plug in 0 here, you are going to get indeterminate form of the form 0 times infinity. So we want to use the L'Hopital rule. Because of this, we want to use the L'Hopital rule. So we write the function in this form. Now, if we evaluate this limit as t approaches 0 from the right of cos t, we get cos 0, then this one to give us sin 0, then this we cannot evaluate this unless we simplify this. So we get limit as t approaches 0 from the right of t over ln 1 over t. Now this will give us 1 and this will give us 0. This will give us 0. Then now from the L'Hopital's rule, this is same as limit as t approaches 0 from the right of the derivative of this and derivative of this. And derivative of this will give us 1 over, and the derivative of this will be the derivative of the function over here, which will give us -1 over t squared over the function itself, which is 1 over t. Now what we are saying is that the derivative of a ln function is equal to u prime over u. So if we differentiate this, we get -1 over t squared, and the function itself 1 over t is this. Now if we simplify this, we are going to get something like this: 1, 0, then this will give us, so this will be limit as t approaches 0 from the right of -t, and this will evaluate to 1, 0, then 0. Now Now this over here too, we follow the same procedure. So we take the limit of each of them. So we apply the L'Hopital's rule over here too. Take the derivative of this. So this will still be equal to the limit as t approaches 0. As t approaches 0, the derivative of this is the same as e to the t, and this will give us 0 all over 1. Then this one also give us limit as t approaches 0 of the derivative of this, you get 1 over 2 root t minus 1 all over 1. Then this, you don't need to apply the L'Hopital's rule, so we get 3 over 1 over here. Now this will give us 1 over 1. Then this will give us, plugin 0 here, we get 1 over 2, then 3. So this is the limit of this vector function.